An absolute value equation. I want you to start thinking of an absolute value this way. You have a number line between my fingers. Agree? I mean, I know there's not really, but you've all seen a number line. Sometimes in classes they have a number line. It has negatives and positives. It has a zero in the middle. So an absolute value is the distance from a certain point on the number line. Okay? So if like I had the number 5, if I went 3 above it, I'd get to 8. If I went 3 below it, I'd get to 2. Okay, so think of an absolute value as a distance. A distance is not negative. Okay, if you took a trip to downtown Denver, that could be a positive direction. If you came from downtown Denver back to your house, it's still a positive direction, even though you went maybe the opposite route. Yeah. Or a point. Okay. And why I say a point is right now it will be from 0. You're absolutely right. But when we start having equations inside an absolute value, then there's something called a critical value. So the critical value right now is going to be 0, but a critical value is a point. Okay. So again, think of your absolute value as you have a number line, you have some location, and you can have a certain distance, and you can have a certain distance. And these could be equal distance. Okay, so that's what I want you to start thinking about a little bit as we build into this. Okay, I gotta flip back in the notes, make sure which. Hey, how are you, Coach? Okay. So, what is the absolute value of 5? Yeah, we said distance has to be positive. What's the absolute value of negative 10 when the negative's inside the absolute value? 10. Okay. So, the absolute value of 3 means the distance from x. Okay. So this, I could plug 3, but I also could have absolute value of negative 3. There's 2 different things that would get me to the same distance. Think of this as your distance. Okay? Makes sense so far? Nothing too goofy? Now, this is probably on the next screen, but if I had something like this, the absolute value of 5 is 5, but because I have a negative outside, you get this. That doesn't mean that the absolute value of 5 is negative 5. The reason the negative 5 takes place is this negative transfers to here. That absolute value sign is outside of it. Okay, so complete the following. Absolute value of negative 82, 82. Absolute value of 57, 57. Which one's bigger? Not here. 82. So it's greater. Okay. Number 2, absolute value of negative 67 is 67. Absolute value of negative 70 is 70. 70 is a bigger number. And just as you play through these, it just works just pretty simple. Greater than 61 and 61. Those are equal. Okay. That help you out? Not too bad so far? So now, the next thing, I'm going to refer to a term as critical value. It's something that you don't have to know exactly yet, but we'll start focusing on it. But let's take a look at this. So, how about the absolute value of x plus 2, the equation x plus 2 equals 3? So, let's think about x plus 2. Set it equal to 0. Let's see, is this what I want to go with right now? No, I'm not going to go here yet. what I'm going to do is this. I'm going to say x plus 2 equals 3. Notice I dropped the absolute value signs. And then I'm going to do x plus 2 equals negative 3. Okay, so let's think about that for a minute. Remember when we did the absolute value of 7, or absolute value of 7 is equal to 7. The absolute value of negative 7 is also 7.
He needs to go to the register office right now.
Oh, right now.
Yes.
David. David here? Okay. Gotta go to the registrar's office? Is he leaving or?
No, he says he has to go there.
Oh, he's on things, right? He's at the registrar's office. Take down the hallway, out the doors. Don't go into the next building doors. Go into those doors at the corner. Okay, so this brought up two equations. So if I solve this, I get 1. If I solve this, I get negative 5. So I get 1, and I get negative 5. Okay. Is everyone okay so far? Yeah.
Wait, so how did you get negative 3?
Okay, so remember, if I took the absolute value of 7, it equals 7. If I took the absolute value of a negative 7, I also get 7. So both the positive and negative component inside an absolute value happen. That's why I create two equations. And basically the rule that I like to follow for Algebra 1, this will work all the way through high school. Change the sign on the simpler side. Meaning, I only have a 3 over here. 3 is a little simpler than x plus 2, right? So I have 3. This just transferred directly. Here, I changed the sign on that. So I had to solve them both. But now, what does this really mean? Well, I'm going to take this, and I'm going to take this right here. I'm going to come down here. I'm going to take x plus 2, and I'm going to set it equal to 0. If I do that, I get x equals negative 2. Okay? This is what's known as a critical value. Okay? So think about where that's at. It's right here. That's negative 2. Agreed? Negative 2 is not the answer. What we're looking for is, what number am I 3 above and 3 below? Well, look at this. I add negative 2. If I go count 1, 2, 3, I get to 1. If I count down this way, 1, 2, 3, I'm at negative 5. So the critical value is what's inside the equation, inside the absolute value that is solved for 0. It's not solved for negative or 3. What am I 3? What value am I 3 above and am I 3 below? And it's kind of a huge, huge idea. Yeah.
So do we always go 3 above and 3 below with everything, or would it just be the equal?
No.
What's over the equal?
So if this is a 10,
You go 10 above and below.
the critical value. Yeah. So what I'm trying to show.
So what's in between?
Yeah. So I'm trying to show, and this is just kind of, you got to use your imagination just a little tiny bit. If I take this negative 2, is this distance and this distance the same? Okay? Does that make sense what a critical value is? Okay? So it's whatever inside the absolute value sign. If it's an equation, whatever inside there, you set that equal to 0, and that finds you the critical value. What am I that far above, and what am I that far below? So this is such a huge concept. And again, and I'm spending time on this because this is like a thing that you could see on like an ACT or an SAT. It might say, Hey, you have this. What's the critical value? Oh, I just take what's inside the absolute value. Notice I said inside the absolute value. Set what's inside the absolute value equal to 0. Solve it. I wind up with -2. So my critical value is -2. And then, hey, what's 3? What is 3 above that? What's 3 below that? And the reason we say what's 3 above and below is a distance. And a distance can't be always the same, but the distance can't be negative. Okay? Yeah.
So why would we do like x plus root is 3 and x plus root is 3? Like, what was the point?
Oh, so what we're doing is we think there's a distance between you and me. I'm going to call you the critical value. Okay? So we could probably measure this distance between us here, right? If I come over here, get to about here roughly, I'm about the same distance away from you, right? I'm just on the other side of you. So you're the critical value. I'm what happens 3 above you and 3 below you, or whatever the distance might be. So you think of this right here as like a distance. This articulates, because it's an equation, some sort of critical value. Huge, huge idea. Yeah. Doesn't make the equation true. Oh, that's correct. So if you were to take -2 and plug it in, if I took -2 and plug it in, I get -2 plus 2, that's 0, right? Absolute value is 0. 0 is 0 equals 3. No. That's why I only made it pink. I'm not calling it an actual solution to the problem. These are my two solutions. -1 and -5 are my solutions. So if I take 1 and plug it in, 1 plus 2 is 3. Absolute value of 3 is 3. Does that work? -5. -5 plus 2 is -3. The absolute value of -3 is 3. Okay? And friends, I tell you, this is such a huge stepping stone. This is not like, this isn't 4th grade math. That critical value is such a huge pivotal thing. And there's so many things that start taking place that are critical values in math, and we don't even call them that later, but right now we're going to say it's a critical value. I mean, you'll have it, especially when you start graphing. These things will all exist, okay? Can I move off of this for right now? Okay. So, for problems 1, 2, and 3, 1, 2, and 3, what do you feel the critical value is? Remember, that's okay. If I take what's inside the opposite value, so what's inside the opposite value, set it equal to 0. 1, 2, and 3. Inside the absolute value, my critical value is 0. So I'm looking for 12 above and 12 below. Here, I'm looking for the critical value. Critical value is going to still be 0. Whatever's inside the absolute value, set that equal to 0. Z is the only thing inside the absolute value. So Z is my critical value on 1, 2, and 3. 0 is my absolute or my critical value. That's what I'm going above and below. So this is, oops. Ooh, I got a calligraphy pen. X equals 12 is one answer. So hang on. Before we made kind of a big jump, well, let's make sure we feel comfortable. If I plug 12 back in for X, the absolute value of 12 is 12. I take -12 and plug it in. Absolute value of -12 is 12. We are going 12 above and 12 below our critical value, which is 0. And it's just asking us to solve it right now, but I want that whole idea of critical value to be a part of what we're looking at. Is everything okay? Yeah, good. seen worse ones that I immediately have to go to. Well, I just register. Okay, so an absolute value is a distance. Okay. That distance is the distance above and below the absolute value. And a distance can't be negative. Big idea, real big idea. Okay, so for our next problem, I'm just going to subtract 3, and I still have absolute value of 16. Agree? My answers are y equals 16 and y equals negative 16. Okay? Let's make sure we can make this work. These are my two answers. Again, I have two components, but if I do the absolute value of the positive and the negative, the absolute value of any number has got to be always positive. Yeah. Whoa. Because my distance is actually 16, what I'm looking for, or a distance plus 3 equals 19. So, because anytime I plug anything into an absolute value, vertical lines, it's going to be a distance. So that's our distance that we're thinking about. So I take 16, plug it in. Absolute value 16, 16, 16 plus 3, 19, right? So I take negative 16, plug it in. Absolute value of negative 16 is also 16. 16 plus 3 is 19. So yeah, there's two solutions that are taking place. So why don't you just put it in the You could, yeah, you're absolutely right. We went real simple on this for now. But that critical value is like, wait a minute, that's not even part of the answer. It's like, that's the point that you're going above and below, is what you're doing. In this case, our critical value would have been 0 because whatever inside the absolute value set equals to 0. Okay, it'll start sinking in, I promise. This still has a critical value of 0. What do you think I should do with that 2 before I get rid of the absolute value signs? Do what? Well, it's being times right now. It's 2 times. Yeah, if I divide both sides by 2, those cancel. 32 over 2 is 16. Yes? My answers are negative 16. Okay? So let's do this again. I know I covered up 2, but we still know the 2's there. If I take 16, plug it in. Absolute value of 16 is 16. 16 times 2 is 32. If I take negative 16, plug it in. Absolute value of negative 16 is 16. 2 times 16 is 32. So again, we have a critical value that we're going above and below, and we're talking about a distance. Those distances go positive and negative 16. Okay. So let me just put off to the side, CV equals 0, CV equals 0, CV equals 0. Okay. All right. Let's see. Let's take care of this critical value here. I have a critical value of 4. Okay. Let's make that 4 a little nicer to look at. Okay. Is 4 my answer? Is 4 my answer? No, it's the critical value. That's what we're going to have the distance above and below. Now I'm going to take this and make 2 equations. Sorry, I just had to breathe for a second. Add 4, add 4. Add 4, add 4. Okay. Let's do the same thing. Okay. Critical value is not our answer. We're just looking for what am I going to be 6 above and what am I going to be 6 below. So let's take our -2, plug it in. -2 minus 4, -6. Absolute value of -6 is 6. It worked. Let's take 10. 10 minus 4, 6. Absolute value of 6 is 6. It's equal. 6 is equal to 6. Let's find the critical value. I'm going to set that equal to 0. Again, that's not my answer. Add 4 to both sides. Divide each side by 2. Is it okay I didn't write every step down? So this is my critical value. Okay. Basically, I want 10 above that and 10 below that. 10 above 2 is what? 12. So let me just, I'm going to write it right here. Let's see if we're right. Do you all agree that 10 above 2 is 12? What is 10 below 2? -8? I think those are our answers, but let's double check. 2x minus 4 equals 10. Add 4, add 4. 2x equals 14. Plus 4, 14, divided by 2, divided by 2. Oh, wait a minute, I got 7. Do what? I think it's positive 2. Ooh. These are off. Hang on. So I get a 7 there. I gotta make this so I can write rather than try and write with my hand up. Let's take this. 2x minus 4 equals -10. Oh, 2x. X equals, divide by 2, -3. Ooh, I was off a smidge here. I think I know I made a mistake on that. I'll erase that so we act like it doesn't exist anymore. Can we just do that? Oh. Let's see if these work. 7, if I plug it in, 2 times 7, 14. 14 minus 4, absolute value of 10 is 10. Okay, you got it right. Whew. My goodness. Take -3, plug it in. 2 times -3, -6. -6 minus 4, -10. Absolute value of -10 is +10. Okay, we did it right. I'm not sure what I wrote here, but that was wrong. I just wanted to see if we could try something. I was making a hypothesis, and I was wrong. Okay, so we can jump off the critical value for right now. Let's just do this. Uh-oh. -8. Uh-oh. Something's bad's gonna happen. Let's take -8, plug it in. -8 plus 3. -8 plus 3. -5. Absolute value of -5. +5. Is +5 equal to -5? Oh, uh-oh. Hang on, let's try here. Plug 2 in. 2 plus 3. 5. Absolute value 5. Is 5 equal to -5? This last part, that it was equal to a number, we said was a distance. Agree? What did I say about distance? Can't be negative. Number 6 is no solution. Didn't work. Okay, so that kind of takes us to a little bit extra, a little bit of a step. If I just have an absolute value, I don't have anything, any negative signs or anything like that in front of the absolute value. Just have an absolute value. Just have the absolute value on one side. The other side is negative. It's not going to work. There's no solution. And that's such a what? You crazy? No. So it's very possible we could get some no solutions. Let's see if we can carry that further to, say, number 7. What do you think number 7's answer has to be? Why? I have this as a negative. There's no solution. There's nothing I can plug in to x and take the absolute value of that to get a negative answer. Ooh.
Is there like a theoretical math pathway possible?
Oh, man. There are some math classes, my friend. There was a class I took in college. It's a senior level math class called Abstract Algebra. Abstract Algebra, I had it twice a week. You had a 3.5-hour lecture twice a week. We had a room about this size and had whiteboards all the way around. It didn't have an electronic board because I'm old and need to move. The teacher would start here with a problem, go all the way on all the whiteboards all the way around. Our final was 4 questions. And we had 3.5 hours to do it. We almost, I don't think anybody got it done. I mean, it was crazy. And it is like the math that you're using like symbols and, forget pi. You're using stuff going, oh, we're talking about the integers. We're talking about the real numbers. We're talking about the rational numbers. We're talking about the irrationals, the complex numbers, like complex are square roots of negatives. It was, whoo! There was times I drove home after that class. I lived 22 miles from campus. I don't remember driving home. That's how scrambled my brain was. It was like, whoo.
Pass the class.
Yeah, I got an A. Yeah, and it was just one of those where you're like, All right, number 8 looks unique. I do have this negative here. Agree? But I'm going to divide each side by -4. And a negative over a negative, we have learned, is a. So this has an answer of x equals 7 and x equals -7. There's 2 answers. Okay, so let's make this work. I take 7 and plug it in for x. Absolute value of 7 is 7. 7 times -4 is -28. Take -7, plug it in. Absolute value of -7 is 7. -4 times 7 is -28. So if you have a singleton negative sign, and that's on the side that doesn't have the absolute value, it's very possible you might not have a solution to the problem. Oh my gosh. Stirrup, my mind hurts. My brain's full. Can I go home? What is that? 24? We'll multiply both sides by -1. Those cancel. Can I stop there? I think so. This has no solution. The reason it has no solution is once I got to just the absolute value, and the absolute value has nothing else but the absolute value, and it's equal to a negative, you jump right to a no solution. Dude, you kidding me? No. Yeah,
Could you technically just not multiply by -1? Like, is anything really do?
I mean, that's the math that we're actually doing. To try and get the absolute value of sign all by itself. That's what we're doing. Holy crow. You had no idea that you're going to walk in on Friday. You're like, I need the weekend to recover. Oh my goodness. All right. Page 43 and 44 are your homework. Page 43 is the only page that has anything. Page 44 is blank.
Well, why did you say 44?
Just so you know, there's a front and a back to that page. I just gave you a whole lot to comprehend. I think you might be able to establish what we did. And nowhere on there does it say anything about a critical value, but I just wanted, it was important for me to say, make sure that critical value was in there for you to have a little bit of a knowledge about. Oh my gosh. I had no idea we were going to step into mud today. Whew, okay. I'd say do the best you can. I bet you there's going to be questions on Monday. I would bet you. Agree? All right, I'm going to stop